All right. This begins lesson 26, and for lesson 26, we're going to be talking about sequencing one job, let me start over, sequencing several jobs through one task. And this is, it's going to be an interesting piece of work, and it's you'll find this covered in your textbook on pages 741 through 752, 741 through 752 of your textbook. This is the last new material of the course, and so it'll be, but I think maybe some of the most hopefully logical topics in the course. Okay, so we're sequencing. It's in the supplement to chapter 17, and again 741, pages 741 through 752, sequencing. We're going to talk today in this video exclusively about sequencing a series of jobs, several jobs that have to go through one production process. And some of the measures of effectiveness that are used are here, and these are described. But flow time, it's which is the amount of time it takes a specific job to flow through the process. Make span, which is going to be one of the common ones that we're going to talk about, which is the completion time for all of the jobs. It says project, but when it's how long all of the jobs are required. And then tardiness, which is going to be how much time the job is late or fails to meet its deadline. In sequencing, there's several ways to approach sequencing. And again, these are all explained, and so I won't go through all of them in your textbook. But the most common ones that you'll see, of course, FCFS, which is the first come, first served. Another process, way to sequence is last come, first served. This would be, in the best way the example I can give is, let's suppose hypothetically you have some jean material or some cloth material, in a sequence of events, the cloth is stacked, and that the blue line here represents one piece of cloth. Once it finishes the previous process, that cloth is stacked one on top of the other. Each piece of cloth that comes in through one process is stacked on top of each other, and then as it goes out to the next process takes this piece of cloth that has come in last off the stack to process it. And so in that case, that would be a last come, first served process. Also, the due date. Another common way of scheduling jobs is by putting them in sequence of which job has the earliest due date or is due most recently. And the other ones that are going to be common that we're going to look up are going to order them in terms of the shortest processing time. So the job that is finished most quickly is sequenced first, and the job that takes longest is sequenced last. And then longest processing time is just the opposite. The job that has the longest processing time gets worked on first, and all the way down to the shortest. So several different ways to approach scheduling. Then there's heuristics. There's rules of thumb, experience that you have with the process about which it should be sequenced appropriately. Okay, so let's talk about this in general. Here's an example, and in this example we have 5 jobs that are numbered A through E, and in this table you're going to see this is you're given in the next column the job's duration, how long is it going to take, and then the when it's due. So this is the information. Now, interestingly, the first question I want to ask you is, how many ways are there to put the jobs into the sequence? And so what this table means, if we put job A in the first, B, C, what this means is that job A will get processed first, job B will be processed second, C will be processed third, D will be processed fourth, and then E will be processed fifth. So the question is, I have for you, how many, for 5 jobs, how many ways, how many sequences are possible? So that's the question. How many job sequences are possible with 5 jobs? Hopefully, I want you to let you think about that for a minute. Well, some people may say 5 squared, but it turns out, if you think about this carefully, I'm going to erase. If you think about this carefully, there are 5. You could, before you make any decision, see if I can diagram this. There are, about which one goes into this box, there's 5 ways, 5 possible choices for these 5 jobs that could be placed in the first order. Then let's just say, then we're going to take A off of that, and then after you assign 1, there's 4 ways that can be assigned, 4 possible choices for this box. And then after we take B off, there's, as you can imagine, hopefully you can see the pattern, there's 3 jobs that could go into this box, and then 2 jobs, and in the last position there's only 1 left. And so the number of jobs is, number of possible sequences is 5 times 4 times 3 times 2 times 1. And that, when you do the arithmetic, that turns out to be 120 possible sequences. And you've seen this factor before. This factor is called is 5 factorial, which equals that 120. So it's 5 factorial. It's 5 times 4 times 3 times 2 times 1. So there's 120. There's 120 possible sequences for 5 jobs. I want to make a side comment, and this is that figure that you've seen before, calculation that you've seen before, 5 factorial. The interesting thing about this is that, unlike linear programming, and even though there's a finite number of choices, unlike linear programming, with sequencing, the only way to guarantee that you have the best solution is to examine and to evaluate all 120 possible choices. And that becomes a problem. And this is turns out to be, sequencing is among all of the hard problems in mathematics. Sequencing is one of the most difficult problems to solve and to guarantee that you have an optimal or the best solution. And here's the reason. Let's suppose instead of 5 jobs, we have now 15 jobs that have to be sequenced. Now, 15 jobs is not a lot of jobs, but 15 jobs. Let's suppose 15 jobs. Well, that's not a lot of jobs, but the problem becomes, but once we look at this number 15 factorial is an exceptionally large number. And if you go to which I'm going to do right now on my calculator, if you go to your calculator and evaluate this, it turns out that 15 factorial is this is going to be equals 1.3. See if I can write this, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 12th power. So it's an exceptionally large number, and that is essentially the number of, as I understand, the number of grains of sand on the earth. And so the problem becomes to know which one of those sequences is the best sequence. You would have to evaluate all of those 1.3 times 10 to the 12th solutions. And so now what researchers, mathematicians have done, have developed algorithms that work extremely fast to try to solve or to get an approximate solution, even though there's not a guaranteed optimal solution. And so let's go forward and look and see how we're going to evaluate this. Here's our job list of jobs, and the way we're going to evaluate this is we're going to pick a sequence, and within this sequence we're going to evaluate how they compare to their due date and how tardy they are. So let's just arbitrarily, I'm going to pick a sequence, and I'm going to choose the first come first served sequence. So we're going to pick, our sequence is going to be A, B, C, D, and E. That's going to be the sequence that we're going to use. And we're going to, and since for A, we're going to write down the duration. A, for each one of these, it takes 5 days. B takes 10, C takes 2, D takes 8, E takes 6. And then we're going to record the due date. The due date is 10 for A. It's 15 for B. It's 5 for C, 12 for D, and 8 for E. So now we want to evaluate within this table. We want to evaluate whether it meets its deadline and if it doesn't meet the deadline, how tardy it is. So everything is gonna start at clock time of 0. And if A starts at 0, it's gonna finish at time 5, because it takes 5 days or 5 hours to finish, and it's less than the due date, so we know that this job is not complete. Well, because it is one process, again, we've got one process, and jobs are coming into this process, and then they're being completed, and then they move on. But as long as task A, for example, is in process, task B can't start. It's being held. And so as soon as A moves on, then B can start. So B, the soonest B can start is at time 5. It'll finish at time 15. That equals the due date. And so it meets its due date, so it's not tardy at all. Now for C starts at time 15. It takes 2, so it finishes at time 17. But in this case, it is tardy, and in fact, it's late by 12 hours. All right, for task D, it starts at 17, and it takes 8 units, so it's going to finish at time 25. Again, that's doesn't meet the 12, and it's late by 13 hours. And then finally, East can start at time 25. With the 6, it'll finish at time 31. Again, it's late, and in this case, it's very late by 23 hours. Okay. So what we know with this sequence, with the first come first served sequence, which leads to this sequence, A through E, we know we've got 3 jobs that are late. 1, 2, 3. So 3 are tardy. And the total tardiness is 6 and 2. That's 8. And the total, that's 8 hours. And then this is 48 hours total tardiness. So then the question becomes, is there another sequence that you can do better on? I'm going to leave that to you for an exercise to do. I'm going to leave a blank slide for you to, if you wish to work on this. But you can check any of these. You can make up any of these and use any of these sequences that you wish. But the only way, again, to guarantee is that you would go through and list and evaluate these all 120. And that's not too difficult to do with the computer. But if this were 15 jobs, then that becomes virtually impossible. All right. So let's look at another one. And here is this is the earliest, as it's indicated here. This is the earliest due date order. And as you'll see, we've sequenced these, we've listed these jobs by their due dates. C is 2, by their duration. I apologize. Again, it's not by their duration. It's that we've listed them by their due dates, even though that happens to correspond to the also corresponds to the shortest processing time. But the due dates for C, as you can see, 5, 8, then 10, then 12, and then 15. So that's the earliest due date. And once we do the evaluation and follow through this, you'll see we have, again, we still have 3 jobs that are late, but our tardiness now has dropped from 48 down to 28 days tardy. So that's a significant improvement. Okay, so I would leave it to you as an exercise to see if there's other sequences that would do better than this, and just to get some practice. And again, this is a slide that you can use as a blank. You can, if you wish, you could print this out. It's posted on D2L, and practice using this job to see if you can develop another sequence that's better than either of the 2 that we've seen so far. All right, that concludes this. There'll be another part where we'll sequence 2 jobs. Excuse me, we'll sequence many jobs through 2 processes.